We are now talking about a very important topic, that is anomalous property of lithium. Like we see over here, we have lithium, sodium, potassium, rubidium, silicium, francium. Since this is the first element, we exclude hydrogen. This is the first element of what we call the alkali metals. It has the very small atomic size. So lithium shows anomalous behavior. So lithium shows anomalous behavior mainly due to two properties. One is its very small atomic size. Its very small atomic size. And second point is its high polarizing power. Its high polarizing power. So when it's highly polarizing, okay, then what happens is that many compounds of lithium are covalent. So this results in what? Many, many compounds of lithium are covalent. Now we know the old adage or the story that like dissolves like. Water is a polar solid. So all ionic compound easily dissolve in that. If you say that lithium compounds are, some of them are more covalent in nature, then they are easily soluble in covalent uh, solvents like benzene, carbon tetrachloride, chloroform, so on and so forth. This is clear. Now, what are the distinctive, what you call anomalous behavior? Let's look at action of air. Let's look at action of air. Unlike other alkali metal which simply burn in air to form the corresponding oxide, potassium, rubidium, cesium form peroxide, and potassium they also form uh, monoxide. So here what happens is that apart from the monoxide, it also combines with the nitrogen in air and it forms the nitride. So other alkali metals, when burnt in air, does not combine with nitrogen to form nitride. Exceptional behavior. So lithium burns in air. Lithium burns in air to form lithium oxide, lithium monoxide. And so this is lithium monoxide. And it forms lithium nitride. Burns in air to, I'd rather say like this, to combine with both oxygen. I can say like this, make it more clear. To combine with both oxygen and nitrogen in air. Both oxygen and nitrogen in air to form lithium monoxide and lithium nitride. Lithium nitride. This is the first anomalous behavior. All the alkali metals, what happens they do? The second one is what? The second one we have is lithium chloride. Now you see, at home, we definitely use sodium chloride. Pure with sodium chloride, which is pure, not the bazaar salt. Remember, bazaar salt contains trace amount of magnesium chloride, which makes it deliquescent. So, if you take pure sodium chloride, keep it outside, nothing happens. It doesn't become wet. Whereas here, what happens? Lithium chloride LiCl, that is lithium chloride. Lithium chloride is deliquescent. What do you mean by deliquescent? Simply it absorbs moisture from the air and becomes wet. What is deliquescent? It absorbs moisture. It absorbs moisture from air and becomes wet. And becomes wet. It's clear. Whereas sodium chloride, potassium chloride, and all other alkali chlorides do not show what you call the property of deliquescency. One more point is that lithium chloride has two water of crystallization. So other alkali metal chloride do not possess water of crystallization. Water of crystallization. Remember, each one is a question, is an MCQ on its own. Like, how would we frame an MCQ over here? We would write it in words. Lithium chloride, sodium chloride, potassium chloride, rubidium chloride. Which has water of crystallization? Simple question. Only lithium has. Yes, clear. Which is soluble in benzene. So here we have the lithium chloride. So, which is soluble in benzene? Which is deliquescent? So you can have lithium chloride, potassium chloride, sodium chloride, and all that. So from each one of these statements, one multiple choice question can be framed. Okay. Then the third one that we have is lithium hydroxide. Is clear. So while sodium, potassium, rubidium system, they are strong hydroxides. They are strong base. Lithium hydroxide, LiOH. LiOH is lithium hydroxide. Lithium hydroxide is a weak base. Why is it different? Because the other alkali hydroxides are strong bases. Is clear? Then we come to the fourth point. What is the fourth point that we have? That lithium nitrate is clear. So generally what happens, like you've seen potassium nitrate, it gives KO and O, this thing. So here what will happen is lithium nitrate, when heated, gives lithium monoxide. So lithium nitrate, LiNO3, lithium nitrate on heating what does it give? We'll write it over here. We have LiNO3 on heating. Oh, I think we'll take it over here. So we have LiNO3 on heating. What will happen? You will get lithium oxide, nitrogen dioxide, Li2O plus NO2 plus O2. In contrast, suppose if I take potassium nitrate, if I heat potassium nitrate, then what is going to happen? It will give potassium nitrite, KNO2, and oxygen. So potassium nitrate will give potassium nitrite. Look at the huge difference in property. This gives the oxide, whereas this will give nitrate. So sodium nitrate will give sodium nitrite and so on and so forth. Only lithium nitrate will give lithium, it will give the corresponding oxide. Okay, we continue with our discussion on anomalous behavior or properties of lithium. So compounds of lithium like lithium fluoride, lithium fluoride, then you have lithium carbonate, lithium fluoride, lithium carbonate, and lithium phosphate. And lithium phosphate are sparingly soluble salt. Are sparingly soluble salt. Whereas look at sodium chloride, freely soluble salt, sodium carbonate, washing soda, freely soluble salt, sodium phosphate. These are all freely soluble salt. Okay, whereas this is sparingly soluble salt. Now we come to the sixth point. That is, if we look at lithium, reactive lithium hydrogen carbonate. See, lithium hydrogen carbonate does not exist. Lithium hydrogen carbonate, that is NaHCO3 sodium bicarbonate, LiHCO3 does not exist. It is clear. It is not obtained in the solid form. It is not obtained in the solid form. Is not obtained. Is not obtained in the solid form. Is not obtained in the solid. When we come to the seventh point is that reaction with ammonia. Reaction with ammonia is very important. Reaction with ammonia. See, when you talk about reaction with ammonia, what happens? Lithium reacts with ammonia to give a compound lithium imide. So the formula will be Li2NH. This is called as lithium imide. Whereas let us say sodium. Vapors of ammonia are passed over red hot sodium. What happens? You get NaNH2. This is called as soda amide. So while others form the corresponding amide, lithium will form the imide. And the eighth point of distinction, what we can talk about over here is the reaction of the carbonate. So lithium carbonate on heating, lithium carbonate on heating forms lithium oxide. So I have Li2CO3. If I heat it, this does not happen with sodium carbonate. It's clear. Does not form the oxide. So Li2O plus CO2. This is clear. So this is how it decomposes, whereas others do not. So this is the consolidated, what you call, story of the anomalous behavior of lithium attributed to the small atomic size and what you call the high polarizing power because of charge to mass ratio. Charge to radius ratio, not mass. Charge to radius ratio. Charge to mass ratio is another term. Now this was about anomalous behavior of lithium. We now talk about diagonal relationship. So what is diagonal relationship? General statement I will explain. Elements belonging to the second period. Elements belonging to the second period, elements belonging to the second period show similarity in property. Show similarity in property to elements belonging to elements belonging to the third period, but of the adjacent group. That's why it's called diagonal relationship. But of the adjacent group. In fact, if you by heart this exam is a question in your school or college exam, 11th standard. This will be one of the what you call definition Vidyas, defined diagonal relationship. So as you can see over here, this red line shows in our example, lithium will show diagonal relationship with magnesium. So many properties of lithium compounds, it is clear, are going to be similar. So you have, if you look at it, you have lithium, beryllium, boron. You have over here sodium, magnesium, aluminium. So what happens is, lithium in our case will show, this is the second period and this is the third period. Okay. Lithium will show many common properties with magnesium. Beryllium will show with aluminium. It's clear. So you will have boron showing with, so if you have, this will be carbon silicon group 14. So you have carbon silicon. So boron will show many properties similar to silicon. So this kind of a, what do you call, behavior is called as diagonal relationship. At the moment, we are concentrating on diagonal relationship between lithium and magnesium. First and foremost, what happens? They have a very, what you call, close atomic radii. So first and foremost, why would they show diagonal relationship? They have very close atomic radii. That's one of the reasons. So lithium has an atomic radii of 152 picometer. It has a 152 picometer, and magnesium will have an atomic radii of nearly 160 picometer. Look at lithium ionic radii. Lithium plus, and we have magnesium plus 2. Lithium plus will have 76 picometer, and this will be 72 picometer. Obviously, because the nuclear charge increases, so ionic radii will be much less. Is this point clear? Then what happens is, the next is, what are all the points that we can think of? This was the first one. The second one that we can think of, look at all the properties we saw. How is showing different property. Now, both lithium and aluminium are harder than other elements in the respective groups. So first is, because if you remember, in alkali metals, when we are talking, we'll come across sodium is so soft, a metal that can be cut with knife. Lithium cannot be cut with knife. Is it clear? So lithium and magnesium are much harder. They are much harder as compared to. They are much harder as compared to other members of the respective group. Other members of the respective group to which they belong. Let us talk of each one of those anomalous property and compare it with what you call lithium and magnesium. First is let us talk about chloride. Remember, lithium chloride was deliquescent, other members were not. So, here both lithium chloride and magnesium chloride are deliquescent. Both are deliquescent. Now that is why we have this give scientific reason why bazaar salt becomes wet during rainy season. Bazaar salt is a raw salt that is we take normally from the straight away from the sea water. That's called bazaar salt. It contains a small amount of what you call uh, magnesium chloride. Magnesium chloride is deliquescent, so bazaar salt becomes wet during rainy season. So that's why we have to purify sodium chloride. One of the reasons why we have to purify sodium chloride is we want to remove these salts like say potassium bromide, magnesium chloride, and all that, so that it does not affect the property of sodium chloride, especially this property of it becoming wet. Then the fourth point that we can think of is look at its action in air. So both because of the high polarizing power, we said lithium compounds are what we call soluble in covalent compound. Yes, here also lithium chloride and magnesium chloride are soluble in ethanol. Are in soluble in ethanol or ethyl alcohol. So we continue with our discussion on diagonal relationship. So we realize that the next one is what? That both lithium and magnesium, burn in air to form the corresponding oxide and nitride. Seventh one, both lithium chloride and magnesium chloride have water of crystallization. Both other halides and alkali earth metals do not have this. Both lithium chloride is 2H2O and magnesium chloride MgCl2 is 8H2O possess water of crystallization. Possess water of crystallization. Both possess water of crystallization. Then what we have? Both their carbonates, both lithium carbonate, and magnesium carbonate. Both lithium carbonate and magnesium carbonate decompose to form oxide. Ninth, just like lithium hydrogen carbonate does not exist, both lithium and magnesium, hydrogen carbonate do not exist in solid state. Do not exist in solid state. Then both are weak bases. they are hydroxides are weak base. I'll give a very interesting example. See, sodium hydroxide, we say, is caustic soda. I mean, if by chance you intake it, it will burn your skin inside. It can be a very, what you call, life-threatening situation. Whereas imagine when we say magnesium hydroxide is a weak base, magnesium hydroxide is used as a medicine antacid and it's used as a laxative. So how weak the base is, you can understand that is so weak that you can ingest it as a medicine. So this is what I'm trying to tell you. Look at sodium hydroxide, not possible. So these are some of the diagonal properties relating to diagonal relationship between lithium and magnesium.